Okay, here's an example of graphing a fairly complicated modified trig function, and I want to go through all the steps to make a really careful graph, but pretty efficiently. And the first observations that we've been making are the amplitude. That's the absolute value of the number that's in front. That's going to be 3. The period is 2 pi over k. That's the number that's in front of x, because that's what does the shrinking or stretching. So that's 2 pi over 4. It's pi over 2. And the center line, the thing that takes place of the x-axis, and it's oscillating around that center, or the book has a very good term for that. That's really on average how high the function is if you look at one cycle. The nice thing about that is it's another one with no calculation required. It's just the vertical shift, and that's equal to 2. Okay? So the next thing that I suggest is finding the anchor point, the first point to plot at the start of the cycle, and that involves finding the phase shift. And what we've been doing is setting this equal to 0. Because if that's equal to 0, the cosine is going to think that it's at the start of the cycle. And that doesn't require a lot of work. You have to be careful with fractions. Dividing by 4 rather, is the same as multiplying by 1/4. Or multiplying both sides by 1/4 is one way to think about it. You could just blindly cancel and get, or blindly go across and get 2 pi over 12. But you want to cancel, and it becomes pi over 6, because that cancels down to a 2 there. So there's our x value. And then to get the y value, you just plug back in, and you should do it carefully, but you should know what happens with this. That's supposed to be 0. 4 times pi over 6, 4 pi over 6, that's 2 pi over 3. They cancel and I get 0. You should always get 0 because that's the whole point. That's why we picked the x. So you just get whatever cosine of 0 is. And if it were sine, you'd get sine of 0. So it's either 0 or 1. Got to pay attention to which one you're doing. Cosine of 0 is 1. So you can get minus 3 plus 2 is minus 1. So my anchor point is pi over 6 minus 1. And let me make some space by just erasing these calculations. These are still really important though. And the center line was equal to 2. And the anchor point is pi over 6 comma minus 1. Okay? And remember, the other thing we did with the period is quartering, because the landmark points appear every quarter period. Remember, that comes from going around the unit circle and knowing that the simplest values, the high, low, and middle values for cosine would be at the quarters of the period, a quarter of the way around the circle. So a quarter period here is pi over 8. Okay, so I'm not really ready to graph yet, unfortunately, if I want to get a careful graph, and if I want to not get confused about my scale. Because I need to know where the heck this stuff is going to be. I need to know how to mark off my scale for my graph. And that's where a table is really useful. So we're going to put a table up here. Doesn't take a long time. You're going to have this information anyway. You might as well write it down in tabular form. So pi over 6 is where I'm starting, and I've calculated that gives me minus 1. Now, what's my next point? Well, that's where the numerical stuff gets a little interesting. We're going to go pi over 8 beyond pi over 6. We're going to add those. And we need a common denominator for that. Well, the common denominator for that is 24. This is 4 pi over 24 plus 3 pi over 24, 7 pi over 24. Oh no, I have to deal with 7s and 24s. Well, that happens sometimes. So the next one is 7 pi over 24. And you know what I'm going to do is I'm going to actually rewrite this as 4 pi over 24. Because a nice little technique here is to get everything in terms of that common denominator. And when we graph it, we're going to see the value of that, because that's going to be how big our tick marks are going to be. And then we're just going to have to count instead of dealing with the fractions throughout the problem. We're just going to concentrate on the fraction stuff right now. Okay, so 7 pi over 24 is our next value. Okay, now we can plug that back in directly if we need to. And as long as you do it carefully and you know your values of cosine, your simple values of cosine and sine, you can do it that way. But we can be a little smarter than that. We know that that's the anchor point of a cosine. If it's not flipped, the anchor point is the high point above the center line. But it is flipped upside down. And so this is actually going to be the low point. So it's going to be coming up from there. So it's going to look more like this kind of picture. But of course our center line is not just the y-axis. Okay? So we're going away from an extreme point, either high or low. The next point, regardless of whether it's flipped or not, it's going to be on the center line. For a cosine, it's going to go from an extreme to the center. The sine, in a way, is even simpler. It starts at the center, but then it goes off. So this one, very nice fact. As long as we know that value, we actually don't have to do any calculation at all. We could do it to make sure that everything's on track, but we can just put the center line value. Then the next one, okay. What's happened here? I added 3 pi over 24. That is super useful because that, let me write it up here too. That's the quarter period, now put in terms of that common denominator that we found to be useful. I just have to now add 3 repeatedly. 10 pi over 24, 13 pi over 24, and 16 pi over 24. These should be different by exactly 1 period. They differ by 12 pi over 24, which is pi over 2, which is the period. So we're good. That's a good check. Okay, so now, let's see. We got this kind of picture, schematically, what's going on. Went from low to center line, then it goes high. Okay, it went 3 up to get from low to center line, 3 more, because again, got to get our high value. Again, if you're suspicious of that quick determination of the 5, plug in 10 pi over 24 into here, simplify it, subtract, you're going to get a very simple number here. You're going to get pi, if you're doing it right. And then you're going to get that 5 coming out of your basic knowledge of the unit circle. You don't really need to do that. You go low to middle to high by going up by the amplitude. Go back down to center line, and then back exactly where you started, because of course 1 period gets you back to exactly where you started. Now we're good. Now we are ready to graph. So erase the scratch work. Finally, we're ready to graph. And I know where to graph. I don't need any negative x's, at least for this period. I need a little bit of negative x, a negative y. Up to 5, and here's 2. I always dot in the center line. Now I knew the center line height a long time ago, but I didn't want to make the graph yet because I didn't know for sure what these guys were. Now I could have preemptively done that. I could have gone ahead and said, look, it's always center line plus or minus the amplitude. So I could have known that the max and min were going to be 5 and minus 1. So you can do that first if you want, and then you can at least have the vertical scale. But you can't fill in the horizontal scale until you do a little bit more work. And now is where that pi over 24 is going to be really useful. It's going between 4 units of pi over 24 and 16. So I need about 16, so let's see, this is 16 pi over 24, and then about half of that, and half. So that's going to be 8 pi over 24, 4 pi over 24. So that's where it's starting, and then I'm just going to put in tick marks. Doesn't have to be beautiful, but this at least means that you're not going to be completely off base. And 7 pi over 24. So here's that. Here's 7 pi over 24. Here's 10 pi over 24. So just counting the tick marks now. 13 pi over 24 and 16 pi over 24. Okay, and now I just put in the y values. Minus 1, up to the center line, up to 5, down to the center line, down down to -1, and I join them together in a nice cosine-like graph. That gets you one period. Counting 3 pi over 24 repeatedly over, beyond where my screen goes, unfortunately, would get you another period. But let's stop there.